Okay, so in this video we shall look into some few examples of increasing decreasing functions, how to solve them, and then we shall see something else as well. Okay, so let's get started. So suppose we have a um, like this x square minus 2x plus 5 divided by 3x square minus 2x minus 5 is greater than half. Okay. Alright, so how to solve this? First of all, make sure that the right hand side is equal to 0. So for that we have to subtract half from both the sides, and then we can do our LCM. Okay, and this becomes 2x square minus 2x plus 5 minus 3x square minus 2x minus 5, and this is greater than 0. So this becomes 2x square minus 4x plus 10 minus 3x square plus 2x plus 5 whole upon 6x square minus 4x plus 10 is greater than 0. So minus x square minus 2x plus 15 divided by 6x square minus 4x plus 10 greater than 0. Now 15 is 3 and 5. So minus 5 minus 3 plus 3. Okay. This is 60. Maybe we can take 2 in common. And then it is 3x square minus 4x plus 10, that is minus 2x. 5 and 3 is 15. So 15 is again 3 and 5. So minus 5x plus 3x minus 5. Or we can write something like this, maybe plus 3x minus 5x. Okay, and now you can take minus x in common, so x plus 5 and plus 3 in common, so again x plus 5 whole upon 2, so 3x, x plus 1 minus 5 is also x plus 1 greater than 0. Alright, so x plus 5, x minus 3, x plus 5, 3 minus x whole divided by, so 3x2 into 3x minus 5 and x plus 1. This is positive, so this is, we can divide both the sides, multiply both the sides by 2, we get something like this. Okay, now look, so again we have something very known. So here we have this one's critical point is minus 5, and here we have a 3 critical point, here we have a critical point of 5 by 3, here we have a critical point of 1. So here we can have minus 5, here we can have minus 1, 5 by 3 and 3. So we have 4 critical points, and hence we have 5 regions, right? So now suppose so here is x plus 5, and we have 3 minus x, and we have 3x minus 5, and we have x plus 1. So now look, but one thing, the numerator is x plus 5 and x 3 minus x, and these are the critical points, so 5 and minus 5 and 3. so we will include them, right? Because on including them it will become equal to 0, which is not a problem. But we cannot include -1 and 5 by 3, because on including these points the equation becomes undefined. So we will place holes on -1 and 5 by 3 critical points, and on -5 and 3, -1 and 5 by 3 we put holes, and on -5 and 3 we put bold points. Okay, now we have 5 regions. These are our 5 regions. Here everyone is positive, correct? Everyone is positive on the right hand side, so our main thing is also positive. That is, my equation is also positive here. Now what about this? In this region we cross this 3 critical point, and 3 belongs to x minus 3, so 3 minus x, so this one becomes negative. This one actually changes, and everyone retains its previous state, so this becomes negative. Now y becomes negative. Now we cross the 5 by 3 critical point, so we move into 3x minus 5, so 3x minus 5, this one changes this time, and everyone else remains the same. Everyone else remains the same as the last state, so this becomes again positive, so this is positive. -1, so this one becomes negative now. Okay, sorry, it should be x plus 5. Okay, just a minute, sorry about this. Okay, so everyone was positive here, positive, 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 so our main is also positive here, so it is positive. Here we have 3, so this will become negative, and everyone will remain positive, so this will become negative. 5 by 3, so this will become negative, and everyone will retain its state, last state, so this is negative, this is positive, this is positive, so this becomes positive again. Okay, on this state we are crossing -1, so this changes, -5 changes. Okay, everyone is positive here, so our main thing is also positive here. Here this is negative, this becomes negative. Here 5 by 3, so this becomes negative, this becomes positive. 5 minus 1, this becomes negative now, this becomes negative, and on the last stage this also becomes negative, this becomes positive. So this is a positive, negative, this is positive, this is negative. So whenever they will tell us this is y, right? This is y. So they are asking us where is y greater than 0. So the answer is these 3 regions, this one, and this one. So our answer will be x should belong to -infinity to -5, and we will not include -5. Why? Because on including -5 it should be equal to 0. So we don't want it equal to be 0. It should be strictly greater than 0. So union this space -1 to 5 by 3, again union 3 to infinity. So this is our answer. Okay. Now if they ask us other questions like where is greater than equal to 0, then we should include -5 now. -5 union this space -1 to 5 by 3, but we will not include -1 and 5 by 3. Why? Because on including -1 and 5 by 3, 3x minus 5 and x plus 1 will become 0, and hence our equation will become undefined, so we will not include, but we will include 3, so 3 to infinity. So this is where it is greater than equal to 0. Where is it negative, strictly negative? Strictly negative is in this space. X belongs to -5 to -1, We will not include minus 5 because on including minus 5 it will become what? It will become equal to 0. So we do not want 0. We want only the negative values. So we are not taking those values. Okay. Union, and what else do we do? We take this one as well. So 5 by 3 to 3. What else? What about this? Then we can, so it will be minus 5, and minus 5 we will include this minus 5 mark. Okay, union, so 5 by 3 to 3, and we will include the 3 as well. So, and where will be y equal to 0? Y will be equal to 0 at x equal to any of the critical points. So it will be minus 5, minus 1, 5 upon 3 and 3. So yeah, so these are the things that I wanted to show. Okay, now we can move into strict increasing and decreasing functions. Okay. So increasing function. So what is a strictly increasing function? Strictly increasing function. A strictly increasing function is a function which always keeps on increasing as the input increases. So suppose let us try out a sequence. So 1 2 3 4 5 6 6.5 7.2 and so on. So maybe this sequence, look at this sequence is always increasing. So this sequence is a strictly increasing sequence. Okay, this is a strictly increasing sequence. But what if the sequence is something like this? This is not a strictly increasing sequence. Now why is that so? Because here we can see that two of the points are equal. Okay, so so on increasing, so they are not increasing always. Look, these 2 points are not increasing, they are in the same state. So it should always increase. So this is basically an increasing sequence, just an increasing sequence or monotonically increasing sequence. Okay, suppose by graph, suppose we have this graph. This is what e power x graph. Okay, forget about this, forget about e power x, just take this as a graph. Now take any 2 points, x1 and x2 on the x-axis. So x1 is actually less than x2. So the image of x1 is fx1 and the image of x2 is fx2. Now look, since x1 is less than x2, then fx1 is also less than fx2. And this is true for all the x1s and x2s. This is true for all the x1 and x2s. What do I mean by all the x1 and x2s? Because look, you can take x1 and x2 here. You can also take some other two points, right? Like x3 and x4. Now look, since x3 is also less than x4, the image of x3, that is fx3, and the image of x4, that is fx4, these are also equal. Look, this is fx3 and this is fx4. So since this is happening, so fx3 is also less than fx4. So this is basically the example of a strictly increasing function. Now you will appreciate it more when I talk about something else. Like suppose you have a equation something like this. Like suppose this is our graph now. If we take x1 and x2 here, this is x1, this is x2. So look, x1 is also here, fx1, and fx2 is here. This is fx2. So look, x1 is less than x2. So fx1 is also less than fx2. But look at one thing. If we can take another x3 here, Okay, now look at one thing. Look at one thing. x3 is less than x2, right? x3 is less than x2. Why? Because x3 is on the right hand side, left hand side of x2. So x3 is less than x2. But fx3 is not less than fx2 here. It is not. It is becoming equal. So it is fx3 and fx2 are equal here. So this is fx2 and this is fx3. These two are becoming equal here. So this curve is not a strictly increasing curve, but we can say that this is an increasing curve. Increasing, monotonously increasing. Monotonously increasing function. Okay, so increasing function, how do we check that something is an increasing function? Suppose we have a function. Suppose we have a function like 5x plus 9, right? So what is the m here? M is 5 and what is c? 9. What is m? M is slope, right? Now what is c? C is the y-intercept. Now this is a linear curve line, so this will go something like this. Okay? This will look something like this. This is y. Now look, this is 9. Okay, this is the origin, this is the x-axis, this is the y-axis, and so on. Now if you take any 2 points on the x, like x2 and x1, if x1 is less than x2, fx1 will always be less than fx2, always. So this is a strictly increasing function. This is a strictly increasing function. Now look, if fx was like minus 5x plus 9, suppose it was minus 5x plus 9, so the line would have been something like this, So here m is basically minus 5 and m is x is basically c is 9. So this, if you take any of the values, like this is x1 and this is x2, so fx1 will always be greater. This is something else, right? Look, x1 is less than x2 here, but fx1 is always greater than fx2. Now this is a example of strictly decreasing function. Strictly decreasing function. Okay. So suppose you have a curve like this, something like this, say something like this. Okay. Now look at this curve. This curve, suppose this is A, this point is B, this point is C, this point is D, this is E, and this is F. Okay. Now all these points are basically on the x-axis. Okay. All these points are on the x-axis. Now, if someone asks us that is this curve increasing or decreasing? Is this curve increasing or decreasing? Then the answer is basically this is neither. Neither is it increasing nor decreasing. Why? Because look, it is increasing sometimes, it is also decreasing, it is also increasing sometimes. Okay, so it is a mixed up combination. Okay, so here we will say that it is neither increasing nor decreasing. But if the question is asked, like in region A to B, in the region A to B, is the curve increasing? Then we will say yes. In this region it is increasing. If the question is like in region A to C, from A to C, is it increasing? Then our answer is no. Because in A to C it is increasing up till B, then it is decreasing. So it is neither increasing nor decreasing here. In question 4, suppose they are asking us, name the increasing regions. Name the regions where the curve is increasing. So where are the curves increasing? The curve is increasing from A to B. Then it is also increasing from D to F. It is also increasing from D to E. Okay, because D2 is also, since it is increasing from D to F, then definitely it will increase from D to E, and definitely it will also increase from E to F. Okay, so these are the regions. So you can say that in these two regions, these two are basically byproduct. Okay, but more importantly, in A to B region and D to F region, the curve is increasing. This is where the curve is increasing. Where is it decreasing? The curve is decreasing from B to D. From B to D, it is decreasing. Okay.